So example 3 starts with something flat, but you're going to be rotating it about different axes. So when you do a rotation, it always turns out circular, but we're not going to make a cone or a cylinder now because I'm starting with a semicircle. So just looking at this first one, I'm going to rotate it about the y-axis. Remember, that's the up and down axis. So it's like some of these points are on the y-axis, so they're going to stay put. But like, for example, this one, let's pretend it actually is at the 4. It's 4 units away, so 1, 2, 3, 4 units away from the y-axis. So sometimes it's going to 1, 2, 3, 4 spin this far away. So that means it's sometimes going to spin in front of the y-axis and hit here, and then it's going to spin behind the y-axis. So if you kind of can picture all of these points, like this guy here, in front of the y-axis, behind the y-axis, in front of the y-axis, behind the y-axis. You can kind of picture a poorly drawn, let's see if I can draw a better circle. It's supposed to be a sphere. So when you spin a semicircle, a lot of times you get a sphere, and I say a lot because the next example will kind of prove it wrong sometimes. But I need to also point out what the radius is. Now remember, the y-axis was my center. You're going around the y-axis. So the farthest distance from this center to the outer side of this sphere, this distance, would be a distance of 4 units. So if I know my radius, then I can find my volume. And the directions ask me to round to the nearest whole number, so I don't have to worry about stopping in terms of pi. So the first thing I'm going to do is 4 to the 3rd power. 4 times 4 times 4 is 64. I'm going to ignore the divide by 3 for a second and just multiply that by 4. And get 256. That number does not divide by 3. So my calculator just spit out 85.333333333333333333. And if it was in terms of pi, I would just stop and say, it's about 85 pi. But it doesn't say that, so I'm going to multiply this by pi. And now I'm going to round and say it's about 268 cubic units. That's pretty similar to what's going to happen on this one. We have the same semicircle, but now I'm going about the x-axis. So again, we're pretending this is a better drawn picture. This dot is on the x-axis, so it stays put. But any point that's not on the x-axis is going to be going in front of it and behind it as it spins around. For example, this dot will go in front of it and behind it, the x-axis, which this is what I'm spinning around. So like this dot will go in front, try again, will go in front of my x-axis and behind my x-axis. This dot will go in front of my x-axis and behind my x-axis. It looks really similar to what we just had, but what I want to point out, it's not the whole thing. I in no way will ever end up in either of these two quadrants because I'm spinning up and down. I'm going above and below, above and below. I am not spinning this way. So because of that, you actually don't have a sphere for this one. You have a hemisphere, half of a sphere. However, it still has a radius of 4 units because, like I said, it's basically that same shape. It's just half of it. So when we go to find the volume of it, it's the same exact shape, but it's just half of it. So yes, we just threw in yet another fraction into an unpleasant formula, but it won't be that big of a deal because it turns out the exact same thing. So I'm going to kind of skip ahead. We said when we multiply 4 times itself 3 times, we got 64. When I multiply that by 4, I got 256. And when I divide by 3, I got 85.333. I'm going to jump to that stage. So if I ignore the 1/2 If I ignore the pi, everything else gave me 85.33333333. So I'm going to pick up from here. I want to take half of that. So when I type that in my calculator, 85.333 times pi, divide by 2 to cut it in half, I end up just getting half of my previous answer. So if before the volume was 268, half of that is 134. A hemisphere is just half of a regular sphere.